Sometimes when you use L'Hopital's rule or you're looking at some of the different limits where L'Hopital's rule comes into play, uh, you've got to take a natural log or maybe something to the power base of e. It can be really tricky sometimes, especially if you wind up in a situation where you've got 1 to the infinite power, 0 to the 0 power, or infinity to the 0 power. Those are the specific indeterminate forms where you have to do something a little bit different. So here we've got the limit as x approaches infinity of 1 plus 1 over x to infinity. What happens here is if you substitute infinity into this guy, what happens is that whole guy goes to 0. Because the top doesn't change, the bottom gets bigger, your fraction gets smaller, and the result of that is you approach 0. So basically what I've got is 1 plus 0 to the infinite power, or 1 to the infinite power. And since this is what we've got, we're going to have to use a little trick where we take the natural log of the function, which allows us to manipulate the function a little bit and get in there. So let's see what that looks like. If I take the natural, if I let f of x equal 1 plus 1 over x ln, or to the x power, if I take the natural log of that, the natural log of f of x, then this is the natural log of 1 plus 1 over x to the x power. Now, this is an interesting thing because we can actually simplify this by taking the power and moving it into the front of the natural log. So an equality statement would be x times the natural log of 1 plus 1 over x. All right. Now, the only problem with this is it's not in a form where we could use L'Hopital's rule because we don't have a fraction. So I create a fraction with one more equality statement, and this is going to look really weird, but I'm going to take this 1 over x and watch what I do. I'm going to say I've got the natural log of 1 plus 1 over x over 1 over x. Now this looks really, really weird, but here's the thing. If I take the natural log and divide by 1 over x, that's the same thing as multiplying by the reciprocal of 1 over x, which is where I started. But the key from this is, from this guy right here, I can now look at using L'Hopital's rule. I can take the limit as x goes to infinity, and now I can look and see what's going to happen. And what happens is, if I put infinity in both places, I'm going to have the natural log of 1 plus 0 over 0. Well, the natural log of 1 is 0. So when you put all those guys in, you get 0 over 0. That's an indeterminate form. I cannot have it. So I take the derivative of the top and I take the derivative of the bottom. Well, remember that on the bottom we're working with, well, let's just do this. F of x will be equal to the natural log of 1 plus 1 over x. So when you take the derivative of that, remember, derivative of natural log is 1 over what's inside the log, 1 over 1 plus 1 over x, times the derivative of what's inside the log. Well, the derivative of 0 is 0. The derivative of 1 over x squared, let's just revisit that real quick, or negative 1. The derivative of that is negative x to the negative 2, or negative 1 over x squared. Okay? So what I've got here, though, is times negative x to the negative 2. Okay? There's my derivative. And we can clean this up a little bit if we want. We can have 1 over x squared times 1 plus 1 over x with my negative sign there, or negative 1 over x squared plus x, because x squared times 1 over x would just be this. Okay, so there's my f prime. G prime, well, if g of x is equal to 1 over x, same thing as this guy. So g prime of x is equal to negative 1 over x squared. Substitute those two different parts in, and let's have a look at what's going on. So my f has become negative 1 over x squared plus x. My g of x has become negative 1 over x squared. Use L'Hopital's rule again and see what happens here. Well, remember that we're going towards infinity, so the way it's written right now doesn't look like it's going to work. But if I have something in the denominator, that would be this guy right here. If I've got something in the denominator, I can multiply by the reciprocal of that. And so my actual problem is going to be negative x squared over 1. Well, we don't want that guy. We want x squared over 1 times x squared plus x. Okay? What we can do from this is factor out an x, because you'll notice that each term has an x in it. So when I do that, I get x over x plus 1. Now when I plug infinity into that, it should work out where I get a 1. So the result of this is when I look at my limit as x goes to infinity, I get all the way over here to 1 right here. And so I come back up and I use this part of my new rule. Okay, so what I'm looking at is the limit then as x approaches a, okay, which in this case is infinity, of e to the natural log of f of x. Okay, well, that happens to be 1. And so the answer for this guy is just going to be E. Now this is a really long problem. There's a lot of steps in it. There's a lot of places to make a little bit of a mistake. It's hard to see that as this limit goes to infinity it's going to be 1, but remember how your horizontal asymptotes work. So once we know the natural log of f of x, once we know that part, we can just substitute it in as the limit right here. Okay, it's a tough problem, and it's one of those problems where you're going to have to practice it a few times. And what I would suggest is work this problem out. You might find a little bit of an easier way somewhere along there to simplify the problem down, but it takes practice to do this. Okay, so there you go. That's using the limit when you have the indeterminate form of 1 to the power of infinity.